This lesson looks at z-scores. What's the difference between the normal curve and the standard normal curve? Using the normal distribution allowed us to calculate probabilities for specific data and only allowed us to look at values that were exactly 1, 2, or 3 standard deviations away from the mean. The standard normal distribution allows us to use a standard curve for all problems and look at values that have a standard deviation of 1.5, 2.3, 0.6, etc. So probabilities of the standard normal distribution. The first one is the mean is 0, and the standard deviation is 1. So if we take a look at our bell curve, here where the mean is, that's going to be 0. We have a standard deviation equaling 1. The graph is symmetrical about the mean, so that still means that 50% is on this side, 50% is on that side. Almost all the data still lies within 3 standard deviations of the mean. So recall our 68, 95, 99 rule from our normal distribution lesson. The curve approaches the x-axis but does not touch it. The total area under the curve is equal to 1 as a decimal, or 100% if we're looking at percentages. And it does follow the 68, 95, 99 rule. So we take our curve because we know that the standard deviation is 1 as we go up. So mean plus the standard deviation would be 1. This would be 2. This would be 3. Going in the negative direction, this would be negative 1. Subtract 1 gets us negative 2. And then we have negative 3. So this is when we're dealing with our z values. We will be converting things so that they're standardized with a mean of 0 and a standard deviation of 1. Using the standard normal distribution curve, we use the letter z to represent the numbers along the x-axis. So underneath our bell curve right here. These values are called z-scores. And they represent the number of standard deviations from the mean. So our first example, a z-score value of 2.3 means that we are 2.3 standard deviations to the right of the mean. So here's our mean. Here's our 1 standard deviation, our 2 standard deviations, our 3 standard deviations. And so 2.3 would be past 2 on the way to 3. So somewhere around there. So there's our 2.3. And it is located to the right of the mean. The area associated with the z-score of 2.3 is everything to the left of that value. So that would be all of this. A z-score value of negative 1.9 means we're looking at 1.9 standard deviations to the left of the mean. So remember that our mean is right in the middle. As we go to the right, we're adding, so it's positive. As we go to the left, we're subtracting, so it is negative. If we look at our left, there would be approximately 1 standard deviation away from the mean, so negative 1. There's our negative 2, so 2 standard deviations away, and our negative 3. So we are looking at negative 1.9. So past the negative 1, but not quite at the negative 2. That gets us a value right in there of negative 1.9. And we still, as we look at our shading, we do still shade to the left. So we're looking at, that's the area that's being referred to for negative 1.9. We can calculate z-score so long as we have the following information. We need the mean, we need our standard deviation, and we need our x. Here's what the z-score formula looks like. So the z is equal to our x minus our mean divided by the standard deviation. Our x value is going to be the data value from the question. The mean is whatever our mean is within that question, and the same with our standard deviation. This equation will change your values from your problem into a z value, where the mean will then be 0 and the standard deviation will then be 1, which gives us the ability to compare a variety of pieces of information that have different means and different standard deviations. As we look at our first example, it says for the normal distribution with a mean of 50 and a standard deviation of find the z-scores for the value of x equals 40. So as we go to look at this, we have a mean of 50, so that tells us that this is 50. Standard deviation of 5 tells us this is equal to 5, and we already know our x. It says find the z-score. So z is a question mark. As we look at our formula, z is equal to x minus our mean divided by our standard deviation. So z is equal to x is 40 minus our mean of 50, and then we need to divide by our standard deviation. So we're going to divide by 5. As we go to do this, you do need to calculate the top first and then divide by 5. So 40 minus 50 is negative 10 divided by 5, which gets us a z-score of negative 2. Not only can we use the formula to find a z value, we can also use it to find other values, such as the mean, the standard deviation, or the x value. For this example, it says, for the following z-scores where the mean is 14 and the standard deviation is 3, determine the value of x. So we're looking at a mean of 14. So mean equals 14. Standard deviation is 3. Determine the value of x. So this is x is a question mark. Looking at our z-score formula, z is equal to x minus the mean divided by the standard deviation. We're going to go and we're going to plug in all the values that we know. And so we have negative 2.5 is equal to, we do not know the x, so we're going to leave our x, minus we do know the mean, so we'll put the 14 in, and then we also know our standard deviation, so we'll put the 3 in for it. As we go to look at it, we need to move all our numbers away from the x. As we go to do that, this one is dividing both of these, where this subtract is happening to only the 14. So if we think about it, if we were to calculate, we'd have to calculate these two first and then divide by 3, which means the 3 is further away from our x. So we're going to times both sides by 3. As we go to do that, we get negative 7.5 is equal to x minus 14. We now have x with the 14, so we need to move that 14 away from the x. Currently it's subtracting. Opposite of subtracting is to add. So we're going to add 14 to both sides. And as we go to do that, this becomes 6.5 equals x. Negative 14 plus 14 is 0. So there is our final answer for x. This example has us solving for our standard deviation. So first thing we're going to do before we worry about the standard deviation down here is we're going to simplify this into one number. So we have negative 1.5 equals, we're going to do the math there and subtract it. 35 minus 44 is negative 9, and divided by our standard deviation. At this stage, we want to be able to get our standard deviation to the top of the fraction. We don't want to leave it in the bottom. The easiest way to do this, because we have one fraction on this side, would be to change this guy into a fraction. We can write it as a fraction over 1. And then at this stage, we could multiply diagonally. So these two would multiply together, and those two would multiply together. As we go to do that, we now have negative 1.5 times standard deviation is equal to negative 9 times 1. Notice that that multiplying got rid of our fraction for us. We can simplify this to a single digit. So we have negative 1.5 standard deviations is equal to negative 9. Now we don't want 1.5 standard deviations, we want just 1, and we want that 1 to be positive. So we're going to, because this is multiplying, divide by negative 1.5. So we're not just dividing by the number, but we're also dividing by the sign. What we do to one side, we need to do to the other. And so as we go to do that, negative 1.5 divided by negative 1.5 is 1. So we're left with 1 standard deviation. Negative divided by negative is a positive. 9 divided by 1.5 is equal to 6. And there's a value for our standard deviation. Our last example has us solving for the mean. So, on the top of the fraction, we have 24 minus the mean. That 24 is closer to the mean than 3 is, so we are not going to move it first. We're going to get rid of this 3, which was dividing. So as we go to do that, we're going to multiply both sides by 3. And 3 times 2.5 is 7.5 equals 24 minus the mean. At this stage now, we are looking at needing to move our 24. Currently that is a positive, so to move it to the other side, we're going to subtract 24 from both sides. 17.5 minus 24 gets us negative 16.5 equals 24 minus 24 is 0. Remember that negative sign is hanging out with the mean, and we have not yet done anything to that mean. So when we write our mean, that minus sign is coming down with the mean. So we have negative mean. Now, if we think about what we've been dealing with, we never deal with a negative mean. All our means have been positive, so that means we need to deal with this negative. Remember, no coefficient that we can see is the same as a coefficient of 1, so that is really a negative 1 mean. So if we want to move this negative 1 to the other side, currently it's multiplying, so we're going to divide both sides by negative 1, and when we do that, we get 16.5 is equal to our mean.